Welcome everyone. Here we are going to do some calculation according to the weight transfer. So in the previous video I give some basic knowledge about the weight transfer. So before you are going to do this calculation, it's better to watch that video. I put that video link in the description. So here we have a racing car and they give some data. So weight is equal 6,950 and the track is equal 1,750 millimeters, and the low level to the center of gravity it's equal to 350 millimeter. So using that data, we need to find the cornering post and the maximum lateral weight transfer and the cornering rate. They give the cornering radius, and we need to find the maximum velocity. Here, step by step, we we can we can do this. We can solve this question. So here and there is another thing in this question. We have part B. So in this video I'm not going to talk about this part B, and the next video I will show you how to solve the part B. Till then, let's go to do the first part. So okay, uh, now we are going to solve this question. Here, first of all, we have to sketch our vehicle and we have to put the data. So here we have the height is 0.35 meters. It's given by the 350 millimeters, but we need to convert it to meters. Here track is 1750 millimeters. Convert it to meters. So here we have to mention the friction force, and here the reaction force act on the wheels. Here this is the center of gravity. So in here we can write centrifugal force is equal mv squared divided by r, and here this is the weight is equal 6,950 Newton. So when we are solving this kind of question, we know in this sport car is not going to rolling. This can be happen only skidding. So in the skidding, we can assume this sport car as a one object. So here this is that. So here this is the friction reaction force, and this is the centrifugal force is equal mv squared r, and this is the friction force equal mu r. So when we are solving this kind of problem, we have to create some formulas. So when we considering these forces, we can write mu r is equal mv squared divided by r. Here we know r is equal to w, it's mean mg. W is equal mg, no? Okay. now I can see both of sides have m, so we can cut it down. Mu g is equal v square divided by r. So we can use this equation for our second question. Here I am going to do the first part. They are asking the first part the cornering force, and they give data the coefficient of friction is equal to 1.5. It means mu equal 1.5. So when we are solving this, the cornering force, it's equal to centrifugal force. So this cornering force equal mv, but here still we don't know what is the r and what is the v value. So we know in here that mv squared r is equal mu mg, so we can use this mu mg. We know mg is equal w and m is equal 1.5 and w is equal 6950. The answer is equal 10,450 Newton. That is our first question answer. So now we are move to next question. In the second question, they are asking maximum lateral weight transfer. So in order to do that, I am going to sketch it again. So I am getting this point as a. So here I know this height is equal to h and this equal to t. So when considering a point, we can write here r1 multiplied by the distance is equal t, and again mv square divided by r, we can multiply by the h, then it's equal to here w, here distance is t divided by h, to t divided by 2, because it's half now. Okay, now I'm going to solve this question and we need to find the r1. In order to do that, here r1 t is equal w multiplied t divided 2 minus mv squared h by r. Both sides we can divide by the t. So here we are getting now we know we can add here for this one equal w. Here t. Now we know w we know and h we know and t we know. We have to substitute that values. Here I mu h. Okay. Now the answer is when we are finding the weight transfer, the normal case, in the normal case we know in here when we are getting the cornering, here r1 minus w1 w some kind of weight, and here add that weight. In the normal case we know both side both r1 and r2 are equal and it's equal to half of the w. So it means w divided by 2 is equal to 3475 Newton. So in the use of this, the weight transfer is equal to 2085 Newton. This is our second question answer. Now in our third question, they are asking the maximum velocity. So and they giving a radius of the corner is equal 100 meters. So in third question, the radius is equal 100 meters. So we know when you are finding the maximum velocity, we know in the previous part we found here that mu g is equal v squared divided by r. Using this equation we can find the value for the velocity. mu g is equal v squared r. Here v squared is mu r g square root. Here mu know r is equal to 100 and g is equal 9.81. Using this, we can get 38.36 meters per second as a maximum velocity. We did the first part of this question, guys, so we have another part to complete. So I will put that part in my next video. You can go and watch it. If you have any problem, any doubt of this part, please put a comment. I will reply you. And do you want to know anything about this? Then you can comment, or you can comment. So if you want to know about this weight transfer, I will put a link in my previous video about the weight and load transfer. You can go and watch it, so you can get the basic idea from that. See you next video. Thank you all.